So the separating techniques which we normally use, uh, if we are using filtration, decanting, or centrifuging, it is normally used for insoluble solids or undissolved solids from mixture. For evaporation and crystallization, it is normally used in what cases? If you want to separate the soluble solid from solution, then we use separating funnel. In what case we use separating funnel? Separating funnel is used to separate immiscible liquids. If you want to separate two or more immiscible liquids, we use separating funnel. Fractional distillation. Fraction distillation, if we want to separate the two or more miscible liquids from each other, the liquids which mix with each other, we can use fraction distillation, or it can be used for gases, a mixture of gases. Reason for that, because what happened first, we can easily convert the gas into liquid and we can carry out the fractional distillation. So if you have a mixture of gases or you have mixture of liquids, we can use fractional distillation. So now I will ask questions related to this part. These are the techniques which can be used to separate the substances from each other. So you have to mention a suitable technique according to the question. So I will give examples, and according to the mixture, you have to decide a technique. And I want participation from everyone. So you can use the chat to state the answer for this activity. Purification or separation, that's the same thing. Number one, we want water from one of them, simple distillation. If you want to separate a solvent from the mixture or solution, we can use simple distillation. Now the question is water from seawater. Seawater is a salt solution. Which technique is suitable? The techniques which you can name here: filtration, decanting, centrifuging, evaporation, crystallization, separating funnel, fractional distillation, or simple distillation. Which one is a suitable technique if we want water? Our main purpose for separation, we want water from seawater. So which technique you think is suitable here? Water from seawater. If we use evaporation or crystallization, we don't get because in evaporation or crystallization, mainly what happened? The water is removed. So when the water is removed, you don't have that water back again. Like you can clearly see, if I will show crystallization or evaporation. So what is happening in evaporation here? You remove all of the water. So you did not collect the water, you actually collect the salt. But in simple distillation, what happened? When you supply, like example, if this was a salt solution or a sea water, when you supply heat energy, the water vapor will rise and they will condense. So when they condense, you collect the water in a beaker, and that is called a distillate. So if you want water from the sea water or a salt solution, then which technique is suitable? That is known as simple distillation. Is it clear? First one. Separating funnel is used for separating immiscible liquid. Immiscible liquid means liquid which does not mix with each other. So here we have a salt solution. So whenever we need a solvent from the mixture, we use simple distillation. So salt will left in the distillation flask and we collect the water in a. The fractional distillation is for miscible liquids and separating funnel is for immiscible. Miscible liquid means which can mix with each other. Another, if we want uh, sodium chloride salt from aqueous sodium chloride, or you can also say salt solution. We want the salt from salt solution. Which technique is suitable? We want a sodium chloride salt from its solution. So which technique is suitable here? What about others? Yeah, that's right. Evaporation or crystallization. Why evaporation or crystallization? Because in both cases we allow the water to be removed. So you can mention any one of them, that is also a right answer, or if you mention both of them, that is also correct. If you want to separate silver chloride precipitate from the mixture, the term precipitate means insoluble solid. Which technique we use if we want to separate the silver chloride precipitate from the mixture? Yeah, so we can use filtration, decantering, or centrifuging. That's right. You can mention any one of them. So filtration, decantering, or centrifuging can be done to separate the insoluble solid. If you want to separate oxygen from liquid air, so if you want oxygen from liquid air, Which technique is suitable? Air is a mixture of gases, but we can condense, we can convert them into liquid state. So example, we have liquid oxygen, liquid nitrogen. So what we can use, the technique which we can use, that is called fractional distillation. So a fractional distillation can be used to separate the oxygen from the liquid air. And if we want to separate the food colors or amino acids, so the technique which we use to separate amino acids, food colors, that is known as chromatography. So chromatography can be used for identification, like to check the purity as well, and it can be used to separate the substances from each other. And if you want to separate water from hexane, which is an immiscible liquid, so if you want to separate water from hexane, immiscible liquid, which technique we should use? So in that case, the preferred technique is a separating funnel, as the two substances does not mix with each other. And if we want to separate alcohol from water, which are the miscible substances, just a minute, I will make a space first. So if we want ethanol from sugar solution or ethanol from water, these are the miscible liquids. So the technique which we use, that is known as fractional distillation. So these are the examples of techniques which we use according to the question. Is it clear to everyone? So you should be able to identify a technique using the information given in the question. We use fraction distillation. Can we use fraction distillation in 6? No, we cannot use. Why we cannot use fraction distillation? Because the two are immiscible liquids. Liquid does not mix. So there are two layers. So we can simply use separating funnel. If it was a miscible liquids, like example, if you want to separate petrol, diesel, these are miscible liquids. So we use fraction distillation. Now more questions related to this part I'll share with you. And I want participation from everyone. So you can use screen annotation to state the answer from the list. The list of technique used to separate the mixture is given below. Chromatography, crystallization. The spelling of crystallization, it can be ZA or it can be SA, both are acceptable. You don't have to bother about that. Diffusion, evaporation, filtration, fraction distillation, and simple distillation. From the list, choose the most suitable technique to separate the following. Water from seawater. Which technique is the most suitable? You can use the screen annotation and type the answer, or you can write in like you wrote in sure simple distillation, you write as D. Is it clear to everyone? Helium from mixture of helium and methane. So we have a mix. Helium and methane are the gases and they are mixed together. So when gases are mixed together, which technique can be used? For gases, we can use fraction distillation. That's right. Ethanol from mixture of ethanol and propanol. So we have a mixture. Ethanol and propanol are liquids. And how you identify they're miscible? Because OL is there with both of them. So it means they're same type of mixture. So we can use fraction distillation. Iron fillings from a mixture of iron filling and water. Iron filling and water. Iron fillings are not soluble in water. So which technique? You can use screen annotation to answer. But it's better instead of writing, better type your answer. Use the screen annotation and type your answer so it will appear as clear to everyone. A mixture of two amino acids, glycine and alanine. How to separate amino acids from each other? Amino acids. Amino acids are colorless liquids, so we don't use diffusion. We use chromatography. So the first, thank you for your participation. The first one, answer water from seawater, that was simple distillation. Helium from mixture of helium and methane, fraction distillation. Ethanol from mixture of, even diffusion can be used. Why diffusion can be used? Because these are gases with different masses, so we even diffusion is acceptable. Ethanol from mixture of ethanol and propanol, these are miscible liquids. Iron filling, so we can use filtration. A mixture of two amino acids, so we will use chromatography. Is it clear to everyone? Okay, moving on to the next question. The question is, what is meant by the term fractional distillation? So basically they're asking the definition of a fractional distillation. So what is the definition of a fraction distillation? Separation, it's a separation of substance on the basis of two or more substances on the basis of boiling point is known as fractional distillation. Not immiscible, it is miscible. Abdullah Sarfraz, separating two or more miscible substance. Miscible means which mix with each other on the basis of the boiling point. Okay, another question, a similar question. A list of technique used to separate the mixture. The name of the techniques are given: filtration, diffusion, fractional distillation, simple distillation, crystallization, chromatography. From this list, choose the most suitable technique to separate the mixture. The technique may be used once, more than once, or not at all. Why it is of 2 marks, Abdullah? The first mark is for mentioning that separating the two or more miscible liquid, and the second mark is for mentioning the on the basis of the boiling point. So you can use any of the technique, you can use once, more than once, or not at all. So it is not necessary that what are the options given, all should be used. So if you want to separate a butane from a mixture of propane and butane, so they are same type of substances, name is similar, miscible substances. That's why they have the similar name. So which technique is suitable? Propane, butane from a mixture of propane and butane. These are two miscible. So we can use fraction distillation. That's right. The second one, oxygen from liquid air. If we need oxygen from liquid air, which technique is suitable? So again, we can use fractional distillation. Water from aqueous magnesium sulfate. What is the meaning? We need water from salt solution. Aqueous magnesium sulfate means salt solution. So which technique is suitable here? That's right. We can use, no, not filtration. We need water from salt solution. So we can use simple distillation. That's right. Because we allow the water to escape and then we condense so that we collect the water. Potassium chloride from aqueous potassium chloride means we need now soluble salt from solution. Potassium chloride salt we need from salt solution. So which technique is suitable if we need the salt from salt solution? It's a soluble salt. If you remember that table which we discussed, so the table which we discussed, that potassium chloride is a soluble salt. So when you need a salt, like example, if I say I have a salt solution, when a salt dissolve in water, it is known as aqueous solution. So you have aqueous solution. You have aqueous solution of potassium chloride means you have a soluble, yeah, you have a salt solution of potassium chloride and you need salt from that. So you cannot use filtration. Why? Because filtration is used for insoluble salt. But we need this dissolved salt from the mixture or solution. So the technique which we can use crystallization or evaporation. But evaporation is not given, so we'll write crystallization. Is it clear? Then silver chloride from a mixture of silver chloride and water. Silver chloride is insoluble. Look, silver chloride, yesterday I gave you one table that which salts are soluble. So silver chloride is insoluble salt. Means when silver chloride is mixed with water, how it will appear? The water will be there and then silver chloride will be there as well. You are able to see the silver chlorides. So how I can separate the silver chloride from a mixture of silver chloride and water? How we can remove the silver chloride salt from water? So if it is insoluble salt, we cannot use crystallization, we can only use filtration. So filtration can be used. And what about the last one? Crystallization or evaporation, Abdullah Sarfraz, is only used for soluble salts, and filtration or decanting or centrifuging can be used for insoluble salts. And the last one, glucose from a mixture of glucose and maltose. So we can use, in that technique, we can use chromatography as well. No, they are not. It's like type of the sugar. So we can use chromatography. Type of sugars are mixed together or amino acids. So we can use chromatography. Is it clear? So the technique, butane from a mixture of propane, we use fraction distillation. Oxygen, we use fraction distillation. Water, we use simple distillation. Water from aqueous magnesium sulfate, we use simple distillation. Potassium chloride, it's a soluble salt, so we use crystallization. Silver chloride, it's insoluble salt, so we use filtration. And glucose, amino acids, yeah, you can mention crystallization, but the best technique is chromatography to separate them. Is it clear? Question 3. And this is a similar question. In question 4, the following techniques are used to separate the mixture. You don't have to write the name, you have to use a letter. If you select simple distillation, write letter A. If you select fraction distillation, write letter B. If you use chromatography, write letter C. If you use filtration, write D. Evaporation, write E. And for diffusion, write F. Methane from a mixture of gases, methane and ethane. Two gases are there. So which technique can be used? A, B, C, D. So which technique is suitable here? That's fraction distillation, that's right. So B. Water from aqueous magnesium sulfate means we need water from salt solution. You just have to use a letter. You don't have to type all. Which technique? Simple distillation, because we need water from, so not B, it is actually A. Because we need water from the salt solution, so we use simple distillation. Glycine from a mixture of amino acid. Amino acids are there. So which technique is suitable? C, that's right, good. Iron filling from a mixture of iron filling and water. Iron fillings are insoluble in water, does not mix in water. So if you want to separate the solid from the mixture, you can use filtration. Zinc sulfate crystals from, we want salt from the solution. A dissolved salt from solution. A dissolved salt from solution. we can use evaporation. And hexane from mixture of liquid, hexane and octane, two miscible liquids. We want to separate two miscible liquids from each other. Miscible liquids, both are liquids. Simple distillation is used to separate liquid from the mixture, but we have two miscible liquids. So when two miscible liquids are there, on the basis of the boiling point, we use fractional distillation. Is it clear? So thank you for your participation. Hexane from a mixture of liquids, hexane and octane. So two liquids are there. So when two liquids are there, we use fraction distillation. If we want liquid, one liquid from a salt solution, in that case we use simple distillation. But if two liquids are mixed together, then we use fractional distillation. Okay, use the screen annotation to answer this. Different methods of separation rely on substance having different properties. Which property does distillation make use of? Simple distillation or fraction distillation? So it use, that's right, A, because on the basis of the boiling point, the substance are separated from each other. Which method should be used to separate mixture of two liquids? Two liquids are mixed together. So when two liquids are mixed together, yeah, that's right. We can use fractional distillation or we can use simple distillation. Yes, thank you, Simon. We will discuss this question at the end. This part is actually related to the apparatus. So you have to memorize the name of this apparatus, because in exam, in paper 6, alternative to practical, the first question most of the time is label the apparatus. So this gas syringe, a stopwatch, stopper, top and balance, a wire gauze, tripod, test tube rack, metallic tongs, spatula, knife, spirit burner, Bunsen burner, separating funnel, thistle funnel, condenser, test tube. Uh, Here you cannot give paper 5 reason for that. Paper 5 based on experiments, like performing the experiment. So you're not performing the experiment. That's why you cannot appear for paper 5, Abdullah Sarfraz. You should appear for paper 6. The combination which you should select, that should be 2, 4 and 6. So again, different types of apparatus. So stand with a clamp, dropper, crucible, a pipette, a burette, measuring cylinder, mortar, pestle, gas jar, wash bottle, conical flask, round bottom flask, flat bottom flask, volumetric flask, thermometer, evaporating dish, as well as watch glass. So these are the common lab apparatus. You should learn the name of each apparatus and the purpose. I shared this slide. The purpose, the use is also given, so you can read the use. It's not you, in exam they don't normally don't ask what is the use of that, but it's for your understanding. You can go through the use as well. So I will share this part with you. You can memorize the apparatus. So the first one, the table gives different boiling temperatures are there: butanol, ethanol, pentanol, propanol. The apparatus shows shown can be used to obtain propanol from a mixture containing butanol, ethanol, pentanol, and propanol. What is this technique? Which technique is used here? What is the name of the technique used here to separate the mixture from each other? Simple distillation or fractional? So this is fractional distillation because you have mixture of liquids on the basis of the boiling point you are separating from each other. So this is fractional distillation. Now my question is, which alcohol I will collect here? Which alcohol will be collected here? Four alcohols are there: butanol, ethanol, pentanol, and propanol. Which alcohol will be collected here? So ethanol will be collected here. Why ethanol? Because ethanol is having the lowest boiling point. So it will vaporize first and it will condense. In the first part, name the item of apparatus label in A and B. What we call this apparatus? What we called A? Which apparatus is A? Yeah, that's right, thermometer. And what about B? Yeah, A is thermometer, that's right. And B is condenser. And it is also called Liebig condenser. You can write condenser or you can also say Liebig condenser. Both are acceptable. Even you write condenser, that is also correct. So A is thermometer, B is condenser. Name this method of separation. What we call this method, we discussed, it's called fraction distillation. Explain why it is safer to heat the mixture of alcohol in the way shown rather than a Bunsen burner. So why here we are using electrical heater? Why not a burner we use? Why we are not using Bunsen burner to heat this alcohol? So normally I mentioned because a Bunsen burner have flame that can cause fire, or it's a flammable liquid, so it can catch fire. So simply you can mention these are flammable liquid. It can catch fire. It's not about breaking glass because it's for safety purpose, because Bunsen burner has flame can cause fire to flammable substance. That's a good answer. Describe how propanol can be obtained from a mixture. Use the data from the table. So how we can collect propanol? First, what we should do, what is the boiling temperature of propanol? It is 97. So we should supply the heat energy until the temperature of this thermometer record 97. So we will collect propanol. And explain why apparatus in the diagram cannot be obtained butanol. So why we cannot obtain butanol? Because butanol is having it's having a temperature higher than the boiling point of water. So the temperature here using an electrical heater cannot rise more than 100, as we are using a water to supply heat energy. So maximum temperature of water can be 100. So butanol and pentanol cannot be vaporized. Is it clear? I did not understand. Okay, less than a minute left. I will share another link and explain this last part.